Thankful to the Object Automation Company. Today, I welcome Mr. Vinay to this program, Artificial Intelligence, today's session. I'm sure that the students get benefit from the Object Automation Company resource persons from day one. I request you all to attend the program very sincerely, just you can get the inputs. If you have any queries, you have to contact the resource persons. They were ready to explain your queries and doubts. Once again, I congratulate all the coordinators of this program, Madam Syamala ma'am and Chechandran sir, Suganya ma'am and Kavita ma'am. Students, kindly cooperate and get the benefits of this workshop. This is especially for students program. So kindly utilize. Thank you everyone.
Shamla ma'am, your mic is mute ma'am.
Yes, ma'am, we can hear you.
You can hear me. So, Mr. Vinay is the Business Development Manager at Object Automation Software Solutions Pvt. Limited. He has completed his graduation at SRM IST and have 3 years of experience in the field of artificial intelligence. His role in object automation is to meet clients and numerous organizations and colleges, giving them an overview of object automation and provide them with services that they need in their organization. So, being an alumni of SRM, I hope students will look upon Vinay and learn a lot from him. I welcome Vinay once again, and over to you, Vinay.
Thank you so much for a wonderful introduction, ma'am. Good morning to one and all present here. I'm as introduced. I'm Vinay Narayan. I did my BTech in the field of mechanical engineering from SRM Katangalathur, and I am working here as the business development manager from Object Automation. I would like to thank the respected conveners and the coordinators, and especially Shamala ma'am, to have arranged this meeting for the students, even during these crises, for the enablement of the students and for introducing them into something new. So today we are going to discuss more about probability, and the topic for today is probability overview with hands-on training. So it's a hands-on. So I would suggest everyone to have a note and a pen with them, so that there'll be a lot of sums in this presentation, and we will be discussing each and everything. And I would expect more response from your side actually. So another gentle reminder, I would like to ask everyone to have a book and pen with yourself, so that you can also solve the sum. And the importance of this presentation is this can be used in your placements. This can be used as when you're writing an entrance exam for the future examinations. There will be a definite question from this presentation, and also it is the base for artificial intelligence. So we are going to cover three basics actually. So three bases. So it will be a very important topic for you all guys. And in the future, in the future seminars, like tomorrow, Abhishek will be presenting about the Bayes theorem, and day after tomorrow, Abhinandan will be presenting about the algorithms. So probability is the base for these topics. So if you understand probability a bit, you will be introduced to artificial intelligence. So hope I'll go into the session. Okay, so I would like to get inputs from your side. What is probability? Everyone would have studied about probability in your school days, even in your college. So what is probability? Can someone explain? Come on, this should be interactive. I need you guys to talk more than what I talk. So I know everyone would have like known probability. So anyone from your side, what is probability? Can anyone explain from your side?
Possibility, sir.
Very good. Thanks, Praveen. Possibility. So what's possibility? Like, couldn't get it.
Like chance to be killed or happened, sir. Or it. Uh,
Okay, nice. So I'll go straight into the presentation actually. So today's topic is probabilities overview with hands-on. So what is actually a probability? Nothing. It's just a chance or the occurrence of an event. Or in other words, we can say it as the likelihood that something can be defined as the event which will occur or not occur. So that's probability. It's the easiest definition. It's a chance or the occurrence of the event. And also, like as I said, probability is one of the most important mathematical concepts that we come across to day life, and this will be particularly important in the fields of business and economic situations. And probability can be used in your personal life too. And everyone knows the formula for probability. It's nothing but the total number of events divided to the total number of outcomes. And the probability, the range of probability, it ranges from a minimum of 0 and a maximum of 1. So this is the base of probability. And what are the uses of probability? The estimation of the probability of the success of a business project, whether it's a success or a failure, where it stands. The probability of the success of an advertising company in boosting the profits of a company, and the estimation of the probability of success of the death of 25-year-old man in the next 10 years and that of a death of 55-year-old man in the next 10 years, and leading to the calculation of the premiums for life insurance. This comes into the banking sectors, and the estimation of the probability of the increase in market price of the share of the company. So as you see here, probability is basically like majorly used in the fields of business where you will be uh, like analyzing the occurrence of the events. So this is where probability gets used. And before going into the sums, I would like to explain or to brush up some important considerations while defining an event. So first of all, a random experiment. A random experiment is nothing but like the outcome has to be among the set of events that are completely known, but whose exact outcome is unknown. It's a random experiment. And as you know, in the probability, each and everything is a random experiment. Most questions on probability are based on random experiment, like throwing off a dice or tossing a coin or drawing a card, picking balls from a sack. So everything is a random experiment. And the second thing is sample space. And sample space is defined as in the context of a random experiment and denotes the set representing all the possible outcomes of the random experiment. Like, for example, sample space when the coin is tossed is head or tail, and the sample space when a dice is thrown is 1, 2, 3, 4, 5, or 6. So that is called the sample space. So the next thing is event. Like the set representing the desired outcome of a random experiment is called the event. So note that we can also say event is the subset of the sample space. If like in the sample space we said that in a dice the sample space is 1, 2, 3, 4, 5, and 6, and the occurrence is 5, then the event will be defined as 5 and the sample space is 1, 2, 3, 4, 5, and 6. So the event occurred is 5. So this is called the sample space and the event. So what is non-event then? The outcome that is opposite to the desired outcome is called the non-event. Note that if event occurs, the non-event does not occur, and it's the vice versa. If 5 occurs, 1, 2, 3, and 4, and 6 doesn't occur. So those are the non-events. So this is the simple thing actually. The impossible event, as in the name, the impossible event, it doesn't occur. Will we get a 7 from throwing a dice? No, we won't. So it's an impossible event. And mutually exclusive event. Mutually exclusive event in the sense a set of events is mutually exclusive when the occurrence of any of them means that the other events cannot occur. For example, if head appears on a coin, tail will not appear. And if tail appears in the coin, head will not appear. So they are mutually exclusive events. And the equally like events. Equally like events in the sense, if two events have the same probability or chance of occurrence, they are called equally likely events. For example, in a throw of a dice, the chance of 1 showing on the dice is equal to the chance of 2 is equal to 3 is equal to 4 is equal to 5 and it is equal to 6 appear on the dice. So everything will be a 1 by 6. So this is called equally likely events. And then the independent events. Independent events in the sense an event is described as such if the occurrence of an event has no effect on the probability of the occurrence of another event. For example, if the first child of a couple is a boy, there is no effect on the chances of the second being a boy. So this is called independent events. So it won't affect the first event, won't affect the second one. So that's called the independent events. And the exhaustive set of events. Exhaustive set of events, a set of events that includes all the possibilities of the sample space. So in a throw of dice, the number is less than 3, or it will be more than 3, or it will be equal to 3. So this is called the exhaustive set of events. And conditional probability. It is a probability of the occurrence of an event A given that the event B has already occurred and it is denoted by P of A and a small dash with a B. So for example, if you draw a red card, then the probability of the red card is being a 4. And like for example, the probability that in 2 throws of dice we get a total of 7 or more, given that in the first throw of the dice, the number 5 had occurred. So these are some of the important considerations while defining an event. So you guys might have like uh, known most of this. This is just for a brush up actually before going into the hands-on or for the sums. So any doubts in the considerations? Are you clear with it? Any doubts from your side? Any queries from your side? Fine. If no, we'll move on to the sums. I hope you're having your pen and the book with yourself so that you can like solve the question and you can explain too. And as I said, you'll be getting these sums. You'll be getting these sums in your placement as well as in your other entrance examinations. So please do concentrate. It will be very, very important for you. And here comes the first sum. Find the chance of throwing at least one in a simple throw with 2 dice. Please note the question. Find the chance of throwing at least one in a simple throw with 2 dice. I'll give you a couple of minutes time for this. You can solve and you can explain how this comes. This one is a very basic question actually. You guys should solve this. So find the chance of throwing at least one in a simple throw with 2 dice. Is anyone solving the question? Praveen or Nitish? And see you guys in the screen. Anyone solving the question?
Yes, sir.
Yeah, please. Since the session is hands-on, I would like everyone to participate here and everyone to like provide your answers and your discussions is much required in this session. Okay, I'll go on with the answer part since it's a basic question and we don't have much time right now. So, find the chance of throwing at least one in a simple throw with two dice. So, what will be the outcomes? Outcomes is 36. The total number of outcomes is 36. Fine, right? And because, like, since why it's 36 is we'll be having a 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, and so on, 6 on 6. So we'll be having a total outcomes of 36. But what will be the total events? See, they are asking find the chance of throwing at least one. So we should have at least one in a throw of two dice. So in the even definition, it will be defined as 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, or 2 and 1, or 3 and 1, or 4 and 1, or 5 and 1, or 6 and 1. So in total, we are having 11 events occurring. So what will be the probability? It is nothing but total events divided to the total number of outcomes. So it's nothing but 11 by 36. So this is the probability of throwing at least one in a simple throw with two dice. So this is one of the basic sums where you will be like facing the examinations, and hope you are clear with this sum. And we'll move on to the second sum. Like any doubts in the first sum, any queries in the first sum, and if you are not able to like open the voice, you can just like type in the chat box so that we can answer. Okay, hope you guys are like clear with this question. So I'll move on with the second one. It's another basic sum where I would like to brush up with your basics, and then we move on to the conditional probabilities and the other conditions. So a random experiment may result in 1, 2, 3, or 4. So there are 4 possibilities. And the probability of first possibility is 1 by 13. The probability of second chance is 2 by 13. And the probability of the third one occurring will be 3 by 13. Then find the probability obtaining 4. I would like to repeat the same question again. A random experiment may result in 1, 2, 3, or 4. If probability of 1 is 1 by 13, probability of 2 is 2 by 13, and probability of 3 is 3 by 13, then find the probability obtaining 4. It's a very simple question. I'll give you 1 minute for solving this question. So anyone from you can explain this in the session. Guys, let's be interactive. Come on. I need more inputs from your side rather than I talking throughout the session and boring it. I need this to be interactive. So the session will be enjoyable as well as informative. Is anyone solving the sum? Please. Okay, then I'll move on. So, as you know, the probability ranges from a minimum of 0 to a maximum of 1. So, we know that the sum of all the probabilities should be like within 1. So, we know that the probability of 1 being occurred is 1 by 13, probability of 2 being occurred is 2 by 13, and probability of 3 being occurred is 3 by 13. And we should have to find the probability of 4 being occurred. And we know that the total is 1. So, 1 by 13 plus 2 by 13 plus 3 by 13 plus the probability of 4 is equal to 1, where we can find all these and we can like differentiate, like difference, we can find the difference by sending all these inputs towards the right hand side, so that I'll be getting an answer named 7 by 13. So probability of 4 being occurred is 7 by 13. So this is the random experiment, like this is the probability obtaining 4 in the random experiment. So any queries for this particular question? Any queries, you can like type this in the chat box too, if yes, or if you know. If yes, I'll repeat the same. If no, we can move on to the next one. Thank you. So these are the basic sums. And now we'll come to the conjunction part. So what is conjunction? What, like, where we use conjunction actually? To join two sentences. In the English grammar, we use conjunction to join two sentences. And what is the role of the conjunctions in this probability? For example, like we'll refer back to the school section. Like whenever we use and as the natural conjunction, joining two separate parts of the event definition, we replace the and by the multiplication sign. Thus, if A and B have to occur, and if the probability of their occurrence are P of A and P of B respectively, then the probability that A and B occur is got by connecting P of A and P of B. So, replacing the and by multiplication sign, we get the required probability. Like where we like use this and is like if someone asks like what is the probability that both hit the target, or both doing the sum or both doing the work, then we'll use the conjunction and. So P of A multiplied by P of B. For example, in the basic sum, if we have the probability of A hitting a target as 1 by 3 and that B hitting the target as 1 by 2, find the probability that both hit the target. So P of A is 1 by 3, P of B is 1 by 2, and they are asking to find the probability that both to hit the target. So P of A and P of B hitting the target, which is nothing but P of A multiplied to P of B, which is nothing but 1 by 3 into 1 by 2. Obviously, it's 1 by 6. So, this is the use of conjunction and. And the another one is the use of conjunction or. Whenever we use or as the natural conjunction, joining two separate parts of the event definition, we replace the or by the addition sign. Thus, if A or B have to occur, and if the probability of their occurrence are P of A and P of B respectively, then the probability that A or B occur is got by connecting P of A or P of B, and replacing the or by an addition sign, we get the required probability. So, for example, in the basic sum, in the example sum, if we have the probability of A winning the race is 1 by 3 and B winning the race as 1 by 2, then find the probability that either A or B wins the race. If they ask both wins the race, then we can like solve it by P of A into P of B by using the and conjunction. But here we are utilizing the conjunction or, where we will be like, since they are asking either A or B winning the race. So P of A plus P of B will be utilized, the conjunction or will be utilized in this particular sum. So the probability of A is 1 by 3, the probability of 2 is 1 by 2, and 1 by 3 adding to 1 by 2 is nothing but 5 by 6. So this is the use of conjunction or. And in some sums, we'll be using both the conjunction and or to solve the problem. For example, the combination of and or will be utilized in such questions where in the first question we'll just check if two dice are thrown, what is the chance that the sum of the numbers is not less than 10? So the even definition is obviously the sum of the numbers is not less than 10. So it can be either 10 or 11 or 12. So what are the events we'll be getting? We'll be getting 6 and 4 or 4 and 6 or 5 and 5 or 6 and 5 or 5 and 6 or 6 and 6. Right. So in the event, they are asking the sum of the numbers is not less than 10. So it should be either 10 or 11 or 12. So we are collecting the events, which is 10, 11, and 12. These are the possible events that can occur. So the probability of getting like sits, like the probability of getting each and every event in a dice is 1 by 6, as you know. So here we have 6 and 4. So the probability of getting a 6 is 1 by 6 and will be denoted as a multiplied sign, 4 as 1 by 6, or which will be added again the 1 by 6 into 1 by 6, or in the place of plus 1 by 6 into 1 by 6 plus 1 by 6 into 1 by 6 plus 1 by 6 into 1 by 6, which is nothing but 6 by 36 or 1 by 6. In these instances, we'll be using both and or. So another kind of sum, another kind of example for the combination of A and or is like in a 4-game match between Karan and Anand, the probability that Anand wins a particular game is 2 by 5 and that of Karan winning a game is 3 by 5. Assuming that there is no probability of a draw in an individual game, what is the chance that a match is drawn? Like the score is 2 and 2. So for example, we can assume that these are the set of events. We can assume that in the first 2 matches Anand wins and the second 2 matches Karan wins. Or first match Anand wins, second match Karan wins, and again Anand wins the match and the final match Karan wins. Or if in the first match Anand wins and in the second and third match Karan wins and in the final match again Anand wins, it's a tie again. Or in the first 2 matches Karan wins and the last 2 matches Anand wins, it will be a tie. Or the first and the third match belongs to Karan and the second and the last match belongs to Karan, or the first and last match belonging to Karan and in the middle if Anand wins the match. These are the probabilities where the tournament ends up in a draw with a score of 2 and 2, which is nothing but the probability of Anand winning the match is 2 by 5. The probability of Karan winning the match is 3 by 5, and that is the given data. And with the help of that, A and A, which is nothing but 2 by 5 into 2 by 5, which is nothing but 2 by 5 square, into, because it's and, into 3 by 5 into 3 by 5, which is nothing by 3 by 5 square. Or again, 2 by 5 into 3 by 5 into 2 by 5 into 3 by 5, which is nothing but 2 by 5 square into 3 by 5 square. In the same way, we'll be getting the same 2 by 5 square into 3 by 5 square plus 2 by 5 square into 3 by 5 square and so on. So when we solve this, 2 by 5 square into 3 by 5 square is nothing but 36 by 625. Since 4 into 9 is 36 and 25 into 25 is 625, and we are having a total of 6. So 36 by 625 into 6, where we get the answer of 216 divided by 625. So hope I am clear up to this. And from now we'll be having the hands-on sums where we'll be using the combinations of and or we'll use and. So any queries up to this? Any queries, any doubts from your side? You can also type in chat box if no. So I might assume you're clear with these concepts. If you're having any doubts, please don't shy to like post it in the chat box or open the voice and you can speak. And I need this to be interactive. Fine. So I'll move on with the sums. Hope you're okay with the basic sums, the considerations, the use of the conjunctions and the use of the conjunctions or and the utilization of both and or. So these are the explanations for now. And with the use of these, we are going to solve the problems, which is like totally going to be hands-on. You guys will be explaining how it can be solved. The questions can be solved. So here comes the first question. In a throw of two dices, find the probability of getting one prime and one composite number. In a throw of two dice, find the probability of getting one prime and one composite number. I'll give you a couple of minutes time for you. Please solve the sum and you can explain. No issues if it's wrong too, we can like correct it. We will like have a discussion so that it will be a great interactive session. Hope you're solving the sum. In a throw of two dice, find the probability of getting one prime and one composite number. Shall I point out the members so that they can answer? Maybe it will be great fun if I point out. Great, Yugender. Great. Yugendran, can you like open the voice and you can like explain how you get 6 by 36? If possible.
So the prime numbers are 2, 3, and 5, sir. And the composite are 4 and 6. So the combination of the both will get the 6. So dividing by the total outcome, it will be 6 by 36.
See, here, like we are using the combination of and or. Right? So as you said, in a throw of two dice, we should have to find the probability of getting one prime and one composite number. And the probability of getting a prime number when the dices are thrown is 3 by 6. Because we'll have 3 prime numbers, right? If I'm not wrong. 2, 3, and 5. And 4 and 6 will be my composite numbers. So, which is nothing but 2 by 6 or 1 by 3. So, the probability of getting a prime number is 1 by 2. And the probability of getting a composite number is 1 by 3. So, I'll just define the event for you. The first number is prime and the second is composite, or the first number is composite and the second is prime. So if the first number is prime, it's 1 by 2 and multiplied. Second is composite, 1 by 3. Or, which will be like included as plus, the first number is composite, which is nothing but 1 by 3, and multiplied by the second is prime. And when you solve this, like which is nothing but 1 by 6 plus 1 by 6, you'll be getting 2 by 6, which is nothing but 1 by 3. Am I clear, Yugendran? Okay. So I would like to explain this again. So we know the even definition. They are asking like to find the probability of getting one as prime and another one as composite. So the first one being prime is and the second one being composite, or the first one being composite and the second one being prime. And we know the probability of getting the prime and the composite. We like put the same in the mathematical terms so that we'll be easily applying the formula and we'll be like getting the solution. So this is how we'll be solving the sums. In the case of two things, with the use of the conjunction and with the use of the conjunction or. So hope I am clear to everyone. So it'll be good if we move on to the next sum. Find the probability that a leap year chosen at random will have 53 Sundays. This is one of the easiest sums where you can solve. Find the probability that a leap year chosen at random will have 53 Sundays. I'll give another couple of minutes of time. I want others to solve the question and to like interact here, like how you can run it. Hope you're solving. I need answers from. You can also like post answers in chat bots. I can see Ilavarasan, Karthik, Gokul, Harish, Jagannath, Jeevita, Christopher. I need answers from you all guys. Ruben, are you solving this one? Ruben Chandran? Did you get the answer? Ruben. Okay, then fine. So no issues. We'll move on with it. So we should have to find the probability that a leap year chosen at random will have 53 Sundays. So what we do is a leap year has 366 days. Normal year has 365 days, and we know that a leap year has an extra day with 366 days. And there will be 52 complete weeks, and 52 complete weeks will have 364 days, if I'm not wrong. And then the 365th day can be a Sunday, or the 366th day can be a Sunday, right? I'll explain it more clearly. We know that a leap year has 366 days, and a 52 complete weeks will have 364 days. So, what will be the 365th day? It can be a Sunday. So, there are possibilities, and the probability is 1 by 7. Or the 366th day can also be a Sunday, if possible, and its probability is 1 by 7. So, getting the probability 1 by 7, or like 365th day as 1 by 7, or 366th day as 1 by 7, we will convert these line into a mathematical expression where we will be getting 1 by 7 plus 1 by 7, and the solution is nothing but 2 by 7. So 2 by 7 is the probability that a leap year chosen at random will have 53 Sundays. See, we'll be having 52 Sundays in a complete week. So the another Sunday will be coming on the 365th or the 366th day. So the probability of both will be 1 by 7 or 1 by 7. And we are using the term or to join the sentence. So 1 by 7 plus 1 by 7 is nothing but 2 by 7. Am I clear with this, sir? Thanks, Noor. So we'll move on to the next sum without like dealing. So this sum, I think we will be like solving these years. Like once the probability had started, you will be getting these kind of sums. And one of the sums is there are two bags containing the white and the black balls. And in the first bag, there are 8 white and 6 black balls. And in the second bag, there are 4 white and 7 black balls. One ball is drawn at random from any of these two bags. Find the probability of the ball being black in color. So there are two bags with us, and there are white and black balls. And in the first bag, there are 8 white and 6 black balls. Second bag, there are 4 white and 7 black balls. And what they are asking is, if we draw one ball at random from any of these two bags, find the probability of the ball being only black. So just like extract the event definition from here so that it will be very, very easier for you to solve the sum. I'll give a couple of minutes of time for you to solve the sum. Please try this and check how it comes. And if you're having any queries, please do post it in the chat box so that I'll be replying it to you. So extract, the first thing in probability is extract the event definition. I'll tell you the simple things. First of all, don't go into the mathematical terms. Just extract what they are asking. Just extract the event definition from the sum. And if you extract it, you'll automatically solve the sum with the use of the and or combination. So someone can see what's the event, like what is the event definition here? Only the event definition. I don't want the answer. Someone can say what is the event definition over here. Okay then. So the even definition here is first bag and black, or second bag and black ball. And the chances of picking up either the first or the second bag are 1 by 2 each. So we should have to check the probability of getting the bag right. So I got an answer from the chat boards. Hi Yugendran, again Yugendran. So I need another Yugendran from the group actually. So fine, great Yugendran, but let's discuss about this. So, like the even definition here is the first bag and black, or second bag and black ball. And the chances of picking up either the first or the second bag will be 1 by 2 each. And besides the chance of picking up a black ball from the first bag is 6 by 14. And the chances of picking up a black ball from the second bag is 7 by 11. In the first bag, there are 8 white and 6 black balls. So what is the chance of picking the black ball? 6 by 8 plus 6, which is nothing but 6 by 14. And the chance of picking up the black ball is like 4 white and 7 black balls, which is nothing but 7 by 7 plus 4, which is nothing but 7 by 11. And the chances of picking up either the first or the second bag is 1 by 2 each. And using these extraction, using this even definition, we will be getting the values like using the ands and ors. We get the probability of picking the first bag is 1 by 2, and the black ball in the first bag is 6 by 14. Or the probability of picking up the second bag is 1 by 2, and probability of like getting a black ball from it is 7 by 11. And if we solve this equation, we will be getting the probability of the ball being black. And the answer will be 41 by 77. Here, Yugendran, as you told, you have found the probability of picking the ball alone. But you should have, but they're asking ball being black from the sack. So you have like found out the ball being black, which is 6 by 14 and 7 by 11. But ball being black from the first bag. So in the first bag, we are picking the ball and we are like checking the black ball. Or in the second bag, the probability of finding the black ball. This will be considered because there are 2 bags and we'll be extracting the answer like 41 by 77. Am I clear, Yudhendra? Like, did you like, okay. Others, like, are you clear with this sum?
Yes, sir.
Yeah. Thank you, Muthu. So, yes. So, we'll move on to the next sum. This one is very, very easy actually. Everyone can solve this sum. Out of 13 applicants for a job, there are 5 women and 8 men. 2 persons are to be selected for the job. And the probability that at least one will be selected will be a woman. So, what is the probability of a woman being selected from the total number of persons? So I'll repeat it again. Out of 13 applicants for a job, there are 5 women and 8 men. So 2 persons are to be selected for the job. Fine. So find the probability that at least one of the selected person will be a woman. So just extract the even definition from the question so that it will be very, very easier for you to solve the sum. See, it's very easy. We need 2 people for the job. I'm running a business, I need 2 people, and that one should be a woman. That's it. What is the probability then? The probability of women being here is 5 by 13. The probability of men being here is 8 by 13. So extract the event alone, extract the event definition alone and solve this. And I'll give you another couple of minutes for the sum. Please solve and get back with your answers. Hope you have extracted the event definition from here. There are 13 applicants again. I need to select one woman for my job. And out of the 13 applicants, there are 5 women and 8 men. So what will be the event definition? So I'll help you out with the event extraction. So I need two persons for my job, and one should be woman. At least 2%. I can hear the word at least 2%. And so the required probability will be given by first is a woman and second will be a man. If first will be a woman and second is a man, it can be in that way. Or first is a man and second is a woman. This can be another case. Or first is a woman and second is also a woman. Because we are using the term at least, I need at least one woman. So it can be two also. Right? So the first one being selected as a woman and second as a man, or first as a man and second as woman, or both be woman. So in that case, this is the event occurring under the following situations. First is a woman and second is a man, which is nothing but 5 by 13. Woman is 5 by 13. Like the probability of picking up a woman is 5 by 13. And the probability of picking up of men is 8 by 13. But here why I used 8 by 12? Since I've already picked first as a woman. So in total there will be only 12. Right? So the probability of picking up a man is 8 by 12. Or first is a man, 8 by 13. And second is a woman, 5 by 12. Or first is a woman, 5 by 13. And second is also a woman, which is nothing but 4 by 12. Are you understanding this equation, how we are forming this equation? Are you getting it? Here you can ask sir, you're saying second is a man, but the probability of getting a man is 8 by 13, right? Then why we should yeah, sure, Yugandran. See, first is a woman, right? And second is a man. So there are there are in total 13 applicants, right? So if first is a woman, it's 5 by 13. So I have selected one woman for the job, and now there will be only 12 applicants, right? There are not 13 applicants now. If I have selected one woman for my job, now the remaining will be 12 applicants. And out of that 12, I can select a man, which is nothing but 8 by 12. Because there are not 13 applicants right now, because I've already selected a woman. So the total number of applicants will become to 12. So probability of getting a man will be 8 by 12 in this case. Or in the second case, first is a man where I will be getting 8 by 13, and now I have gave job for one man. So in total there will be only 12 applicants, and the probability of woman being enrolled in my academy is 5 by 12. And in the third case, first is a woman and second is also a woman. So first is a woman, which is nothing but 5 by 13. And if I select one from the woman, the total number of applicants will be 12. And the total number of women will be 4 because I have already given a job for one woman. So the probability of the remaining, the second woman, will be 4 by 12. Am I clear now? Great. So when we solve this, we'll be getting the answer as 25 by 39. I'm not coming into the calculation part. We just need to know the concept. I don't want you guys to go and calculate and get the answer. I just want you guys to get to understand these concepts, because in major of the placements and major of the entrance examinations, they will definitely give you a sum over these kind of problems with the use of the and or conjunctions. So we are applying both and or in these particular sums. So hope I'll move to the next sum if you're all clear with the sum. And the next sum will come as the probability that A can solve the problem is 2 by 3 and B can solve the sum is 3 by 4. They have directly given the probabilities. If both of them attempt the problem, then what is the probability that the problem gets solved? Just extract the event definition. Just extract how the event definition comes. We are sorted with the concept. See, they have given the probabilities of A being 2 by 3 and B being 3 by 4. Both of them are attempting the problem. What is the probability that the problem gets solved? See, even A can solve the sum, B can solve the sum, A can't solve the sum, B can't solve the sum, or both can solve the sum. So what will be the event extraction? And if you find out the event extraction, you can do the calculations and you can find the answers. I'll give a couple of minutes time for you guys to go through it. Kavi Bharati, you can also come up with the answers and you can explain it here. So someone can come up with the even definition. I don't need the answer. I just want you guys to know the concept. So what will be the even definition here? Okay, then I'll move on with the solution. C. The probability of A solving the problem is 2 by 3, B solving the problem is 3 by 4, and they are asking the probability that the problem gets solved. See, two persons are solving the problem. I don't need what they are doing or I just need that probability, that problem to get solved. So either some of them, either A or B can solve the problem. Like if A solves the problem and B does not solve the problem gets solved. Or A doesn't solve the problem and B solving the problem gets solved. Or both A and B can solve the problem. Both A and B solves the problem. So if A solves the problem, it's 2 by 3. The probability is 2 by 3. And if A doesn't solve the problem, it's nothing but 1 minus 2 by 3, which is nothing but 1 by 3. And if B solves the problem, it's 3 by 4. If B doesn't solve the problem, it's obviously 1 by 4. 1 minus 3 by 4. And if both of them solve the problem, it's the same. So A solves the problem, which is nothing but 2 by 3. B doesn't solve the problem, and B doesn't solve the problem. So, and in the sense multiplied, B doesn't solving the problem is 1 minus 3 by 4, which is nothing but 1 by 4. Or A doesn't solve the problem. A solving the problem is 2 by 3. And A not solving the problem is 1 by 3. So 1 by 3 and B solves a problem which is nothing but 3 by 4. Or A solves the problem 2 by 3 and B solves the problem 3 by 4. If you calculate this equation, you will be getting the answer as 11 by 12. So 11 by 12 is the probability that the problem gets solved. So am I clear with this sum? Should I explain it again? Am I clear with this sum? Everyone? Okay, I'll assume I'm clear with this sum. This is one of the easiest sum for today actually. And I'll move on to the next sum. The probability that Arjit will solve a problem is 1 by 5. Probability that he solves at least one problem out of 10 problems is. So this is a kind of a non-event sum actually. See, they have given the event. He is solving 10 problems. What's the probability that he solves at least one problem out of the 10 problems? So what is the probability of solving the problem? Okay, or in other words, what is the probability of the event here? See, the probability of the event is 1 by 5. So what is the probability of the non-event? Come on guys, the probability of event here is 1 by 5. What's the probability of a non-event? The event is 1 by 5. What is the non-event? Great, it's 4 by 5. So 1 minus 1 by 5, which is nothing but 4 by 5. So what they are asking is, what is the probability that he solves at least one problem out of the 10 problems? So there are 10 problems in total. And the probability of non-event will be 4 by 5. Because they have given solving the whole sum, but the non-event is 4 by 5. So we can assume it as 4 by 5 in the powers of 10. Like he solves no problems, that he doesn't solve the first problem, he doesn't solve the second problem, he doesn't solve the 10th problem too, he's not solving. So that is a non-event, right? So the probability of non-event is nothing but 4 by 5. Why in the powers of 10? Because it's out of 10 and we are solving it as OR. He might not solve the first problem, or he might not solve the second problem, or he might not solve the third problem in the same way as such that he might not solve the 10th problem. So it's nothing but 4 by 5 power 10. And they are asking possibility of the event. So we have found the probability of the non-event. So what is the probability of the event? It is nothing but 1 minus probability of the non-event. Because we know the probability of an event when added to the probability of a non-event is 1. So the probability of event is 1 minus probability of the non-event, which is nothing but 1 minus 4 by 5 the whole power 10. I'll explain this sum again. They are asking whether he solves, like, what's the probability that he solves at least one problem out of 10 problems. So here the probability they have given as an event where he'll be solving this problem as 1 by 5. So what is the probability of non-event, which is nothing but 4 by 5? And since he is solving the 10 problems, as I said, he may not solve the first problem, or he might not solve the second problem, or he might not solve the third problem. So it is nothing but 4 by 5 the whole power 10. And probability of the event occurring will be 1 minus the probability of non-event. That's the solution. Am I clear with this sum? Great. I need others to like respond because I am finding only Yukendran responding to my questions. I need others to. Since it's a hands-on like, session, it will be very important for you guys. So I need interaction from you all. Fine and hope. I assume. Thanks. Okay. So I assume like everyone had understood this sum. I'll move on with the other things now. Since time is less, I'll like move on fast. Again, a same kind of sum. The carton contains 25 bulbs, 8 of which are defective. What is the probability that if a sample of 4 bulbs is chosen, exactly 2 of them will be defective? A sack contains 25 bulbs. A carton contains 25 bulbs. 8 are defective. So what is the probability that in the sample of 4 bulbs is chosen, exactly 2 of them will be defective? It's a kind of a permutation and combination sum over here. You will be using a permutation and combination concept here, and then you will be finding the required probability. Okay, I'll just jump on to the solution since we are having little of time. So the carton contains 25 bulbs, 8 of which are defective. So the non-defective ones are 17 by 25. What is the probability that if a sample of 4 bulbs is chosen, exactly 2 of them will be defective? So we are selecting 2 bulbs from 4 which are defective. So the probability that exactly 2 bulbs are defective and exactly 2 are not defective will be given by the first thing is 4C2, where we are choosing 2 bulbs which are defective from a total of 4 bulbs. So 4C2, we are selecting 2 from 4 bulbs. And 8 by 25 is also defective, right? It can also be defective. And if we like, they are saying like 2 bulbs will be defective. If we select one from the bulb, it's 8 by 25. And from the remaining, we have already selected one, which is 8 by 25. So one will be subtracted. So in total now, there will be a 7 by 24 bulbs which are defective, right? And the probability of getting non-defective is nothing but 17 by 23, right? If we have like chosen 2 already, the remaining non-defective will be 17 by 23. And it's like repeating. If you like, I'll explain this to you again. It's a repetitive process. We are taking one and one again and again. They are exactly asking the probability that exactly 2 bulbs are defective and exactly 2 are not defective. So exactly 2 are defective in the sense 4C2, we are selecting 2 from 4, which is a direct data given to us, and 8 by 25 and 7 by 24. Okay, and the remaining, what will be the remaining? Like we have already chosen the defective ones. Now we are choosing the non-defective ones. So in the non-defective ones, we'll be having, like there'll be a sum of 23 bulbs, and in here, and we'll be having a 6 which are non-defective. We'll be selecting 6 from 23. So the probability is 17 by 23 as the non-defective, and now another one will be 16 by 22. And if we solve this, we'll be getting an answer of 20 by 39. And this process is called as the repetitive process. We are not like picking up the bulb and we are not storing it again in the sack. If we are picking up, it's done. We have picked it up. It's a non-repetitive process. Am I clear with you guys? Am I clear with this sum? Anyone?
Yes, sir.
Okay. So hope we'll move on to the, like, if you have any, like if you guys find any doubt, please stop me and you can like get the solution. I will explain it to you again. We'll move on to the next sum. Out of 40 consecutive integers, 2 are chosen at random. Find the probability that their sum is odd. A very, very easy sum this one, and you can like go on to solve this. So there are 40 consecutive integers. And how many consecutive integers will be having as odd and how many will be having as even? So I'll dive straight into the answers. So in a 40 consecutive integers, we'll be having 2 or 20 odd and 20 even integers, right? If I'm not wrong. Like 1, 3, 5, 7, 9, 11, 13, 15, 17, and so on up to 39 will be odd, and 2, 4, 6, 8, 10, and so on up to 40 will be even. So in total, we'll be having 20 odd and 20 even integers. And the sum of two chosen integers will be odd. Only if, like, first is even and second is odd. If we add, like, if we add first is even, if we add 18 and the second is odd, which is 11, we'll be getting a sum as odd, which is nothing but 29. Or the first number as odd and the second number as even, like 21 plus 12, it's also an even. Sorry, it's also an odd. So we'll be getting 33. So first is an even and second is odd, or first is odd and second is even. So what will be the event extraction or event definition? It will be first is even and into the probability of second is odd, or which is nothing but plus first is odd and the second is even, which is nothing but probability of first being even is 20 by 40, probability of second being odd is 20 by 39, because it's again a non-repetitive, and first being odd, which is nothing but 20 by 40, into probability of second being even is again 20 by 39. So we will be getting the answer as 20 by 39 if we sum this solution, if we sum this equation. Am I clear with this sum? Should I explain this again? We are dealing with some non-repetitive sums here. So are you clear with this sum? Anyone? Any queries over this sum? Okay, then I'll assume like you guys are clear with the sum, and I'll move on to the next one. From a bag containing 8 green and 5 red balls, there are 3 are drawn one after the other. Find the probability that 3 balls being green if the balls drawn are replaced before the next ball is being picked, or the balls drawn are not replaced. See, here we are having two cases, one being non-repetitive and other being repetitive. So, in the bag, there are 8 green and 5 red balls. 3 are drawn from the bag. And they are asking to find the probability of 3 balls being green if the balls are drawn and they are replaced before the next ball is picked. And in the second case, they are asking if it is not replaced. So here in this case, we'll be having two cases, right? So in the first case, when the balls drawn are replaced, we can see that the number of balls available for drawing out will be the same for every draw. If I am picking a green ball and if I replace it again, it will be the same, right? There won't be any change. It will be the same probability. So this means that the probability of green ball being appearing in the first draw, green ball in the second draw, and as well as the third draw are equal to each other. So probability of like drawing a green ball is 8 by 13. In the first draw, it will be 8 by 13. Again, I am like putting that ball in the sack itself. Again, if I draw, it will be 8 by 13. I am again like putting that ball in the sack itself, in the bag itself. Again, if I draw the ball, I'll be getting only the same probabilities, which is nothing but 8 by 13, 8 by 13, 8 by 13. Okay, so here in the uses of like if we get to solve this equation, you will be getting the answer. See, we are drawing 3 balls. I'll repeat it again. We are drawing 3 balls. Okay, so first ball is being drawn, which is nothing but 8 by 13. I am again repeating it by putting the ball inside the bag again. Again, if I pick it, I'll be getting 8 by 13. I'm using the term and over here. And again, if I pick something, I'll be getting 8 by 13. So if I solve this equation, which is nothing but 8 cube by 13 cube, I'll be getting the required solution. And if the balls are not being replaced again, if I'm picking the 8, if I'm picking 8 by like a green ball from the bag, it will be 8 by 13. And I am not putting the same in the bag. I have like kept it aside. And now my probability for drawing a green ball will be 7 by 12. I have kept it aside and now it will be 6 by 11. It's a non-repetitive process where I am not drawing the, like I'm not placing the ball again in the black. So it gets decreased. Are you guys able to understand what I am saying here? Okay, I assume like everyone had understood the concept over here over this sum. And I'll move on to the next sum. A box contains 2 tennis, 3 cricket, and 4 squash balls. 3 balls are drawn in the succession with replacement. Find the probability that all are cricket balls. The first is a tennis ball, second is a cricket ball, third is a squash ball, all 3 of the same type. So here I'm just moving with the answers since we are having little of time. So see, the probability of like picking up a cricket ball is like 3 by 9. Probability of picking up a tennis ball is 2 by 9. A squash ball is 4 by 9. And in the first case, they are asking the probability that all are cricket balls. So if all are cricket balls and we are like replacing it, if we pick a ball, it's getting replaced. So it's nothing but 3 by 9 and 3 by 9 and 3 by 9. All 3 are cricket balls. And here, the first is a tennis ball, 2 by 9. We are replacing it again. Second is a cricket ball, 3 by 9. We are replacing it again. Third is a squash ball, which is nothing but 4 by 9. And we solve this, you'll get the answer. All three are of the same type. All three of the it will be three cricket balls or tennis balls or squash balls. So it will be in that case. So 3 by 9 cube plus 2 by 9 cube plus 4 by 9 cube. If we solve this equation, we will be getting the answer. So I'm moving a little bit faster here. Are you guys able to understand? Are you guys able to understand this sum? Because this one is very easier sum in your like age. Okay, then I'll move on with the next sum. It's a kind of a ratio sum. The ratio of number of officers in the ladies in the Scorpion squadron, in the Gunner squadron are 3 is to 1 and 2 is to 5 respectively. And an individual is selected to be the chairperson of their association. The chance of that this individual is selected from the Scorpions is 2 by 3. Find the probability that a chairperson will be an officer. So here, the squadrons ratio is 3 by 1, which is nothing but like their possibility will be 3 by 4, and the gunner squadron will be 2 by 5, 2 is to 5, where their ratio will be 2 is to 5, where 2 by 7. And we are seeing that the probability of each individual from Scorpion being selected is 2 by 3. So it's nothing but 2 by 3 into 3 by 4, and the remaining 1 by 3 into 2 by 7, where I'll be finding the probability that the chairperson will be an officer. So here we'll be using the term like 2 by 3 and 3 by 4 into 1 by 3 and 2 by 7. So I'll be sending these sums to you through the YouTube link and everything. You can again go through it and you can like ping me back if you are having any doubts over these sums. And I'll just brush you through the other sums too. They have given the probability like for a man being alive in 35 years is 3 by 5 and his wife being alive is 3 by 7. Probability after 35 years, what will be probability then both will be alive. If both will be alive, both 3 by 5 and 3 by 7 will be alive. And only the man will be alive. It's an OR question, 3 by 5 into 4 by 7. Like since the wife will not be alive, only the wife will be alive, then it's nothing but 2 by 5 since the man will be dead, and 3 by 7. At least one will be alive, then we'll be having three cases. Either the man can be alive, or the woman can, or the wife can be alive, or both of them can be alive. So these are the cases. And the last sum, A speaks the truth like 3 out of 4 times, the probability will be 3 by 4. B speaking the sum 5 out of 6 times, probability being 5 by 6. What is the probability that they will contradicate each other in stating the same fact? So if A speaks 3 by like truth, it will be 3 by 4, and B not speaking the truth 1 by 6, or A not speaking the truth 1 by 4 and B speaking the truth 5 by 6. If we solve the solution, we'll be getting the answer as 1 by 3. So this is all I have for today actually. Hope you guys have understood the sums. The last few sums I have been a little quicker since like the time was like it was nearing, and hope you guys understand the concepts of probability, since the probability is the base for artificial intelligence. And here in object automation, we provide courses on Python, data science, quantum computing, and so on, as you see in the screen. So if you wish to join us, if you wish any training or internships, you can contact us. You can like go through our website and you can check our organization. So hope you had a great session. It was a wonderful session with you all. Thank you for the time.
Thank you, Vinay. It was really a wonderful session.
Thank you so much, Kavita ma'am. Thank you. Students, if you have any queries, please feel free to ask me here. hope we are clear with the session. So, and if you are having for like, I'll be sending you this document for sure. You can go through it. You can keep it as a reference. And if you are finding any queries in the future, you can definitely get back to me.
Students, if you have any questions, please ask. Vinay sir is ready to answer your questions. Students,
No questions? Shall we end the meeting?
Yes, ma'am.
Can one student give a feedback? One student? Anyone? Muthu Prabhakaran,
Yes, ma'am. No,
can you give a feedback? Praveen?
yes, ma'am.
Okay, ma. Who is going to give the feedback? Okay, Muthu Prabhakaran. Good. You are able to unmute Muthu Prabhakaran?
Yes, sir. Yes, ma'am. I can unmute, ma'am.
Okay, okay.
It was a wonderful session, ma'am. I have many questions got now. நிறைய பார்த்தேன், நிறைய கத்துக்கிட்டேன் நான் இந்த செஷன்ல.
Okay.
எனக்கு என்னன்னா இந்த பிபிடி கொஞ்சம் ஷேர் பண்ணா கொஞ்சம் பெட்டரா இருக்கும் மேம். சார் சொன்னாரு, இந்த ஷேர் பண்ணிட்டீங்கன்னா கொஞ்சம் நல்லா இருக்கும். ஸோ தட் நாங்க இன்னும் ஃபியூச்சர்ல வந்து நாங்க எப்படி அட்டன் பண்ண தானே போறோம் கேம்பஸ் இன்டர்வியூலாம். ஸோ அதுக்குலாம் இந்த கொஸ்டின்ஸ்ல மேபி வரலாம்ல. ஸோ அதுக்கு நாங்க ப்ராக்டிஸ் பண்றது யூஸா இருக்கும்.
Okay, I'll ask sir to send you
கண்டிப்பா
the
கண்டிப்பா
PPT.
share the recording of the session too. Thank you for the feedback, Muthu. And thank you for the interaction.
தேங்க்யூ சார், தேங்க்யூ சார். இட் வாஸ் வண்டர்ஃபுல் செஷன் சார். நிறைய நீங்க வந்து ஸ்பேஸ் கொடுத்தீங்க பசங்க பேசுறதுக்கு, அது ரொம்ப நல்லா இருந்துச்சு. பட் நிறைய பசங்க பேசல. என் ஃப்ரெண்ட் யுகேந்திரன் பேசினா, அப்புறம் ஒருத்தர் பேசினார், அவ்வளோதான். நான் சாட்ல தான் பெரும்பாலும் பேசிட்டு இருந்தேன்.
No issues, no issues. If you guys understand the concept, I'm very happy for that.
கான்செப்ட் நல்லா புரிஞ்சுது சார். நைஸ் இன்ட்ராக்ஷன் சார். தேங்க்யூ சார்.
Thank you again.
So I think we can end the session. I request Mrs. Suganya, Dr. Suganya, to give away the vote of thanks.
Thanks, ma'am. Good morning, everyone. We have reached the end of this beautiful function. Today, I am Dr. T.S. Suganya. Take the opportunity to put my gratitude into words. First and foremost, I express my heartfelt thanks to our management for arranging such a wonderful event. I extend my gratitude to our honorable guest speaker, Mr.N.Vinay, Business Development Manager, Object Automation Software Solutions Pvt. Limited. Thank you, sir, to take out time for his busy schedule to grace the event, for enlightening us with your inspiring and motivating words. Thank you so much, sir. Also, I would like to thank our beloved Dean, Dr. C. Sundar. Thank you, sir. I thank you, our well-wisher, VP Academic and VP Admin, for gracing the occasion, supporting us in all the ways. Thank you, sir. My heartfelt thanks to our head of the department, Dr. R. Agastya, Professor, BCA Department, for standing with us in each and every moment and clearing all difficulties we faced in organizing this event. Thank you, sir. I thank my organizers to arrange this session, Mrs. Shamla Devi ma'am, Mrs. P.M. Kavita, Dr. S. Jayachandran, and myself for the continuous support to success this program. Thank you, ma'am. I thank all my fellow faculties who support me in organizing the event as a great endeavor. And also I thank our participants and future generation for showing their interest in this program. I would end my speech here. Thank you, one and all.
Thank you, ma'am. Students, tomorrow we have another session at 9:30. from Mr. Abhishek Sharma. Hope you are all attending it. You have to know the latest things which are going on in AI. So you can come prepared with the topic so that you can ask questions, you can interact with the resource person and utilize it to the best. Okay. Not like today, only a few students talked or spoke or they were answering. Tomorrow, I want everyone to be interactive. You have to practice being interactive first. That is the first and foremost thing that you have to practice. Okay? Thank you so much, Vinay. Thank you, Kamini.
Thank you so much.
Thank you, Vinay sir.
Thank you.
Thank you for giving this workshop. Thank you.
Thank you so much. Thank you, ma'am. Thank you, sir. Thank you, Suganya, ma'am.
Thank you. Thank you, sir.
Can we end the session, Vinay?
Sure, ma'am. We'll end the session right now.
Okay.
Okay.
Bye. Take care.